Hello, everybody. Welcome back to another great learning session. So, we would like to wait for a couple of seconds and allow some more attendees join in before we get started. Thank you. Great. I see a wonderful number there. So, I think we can start. Once again, hello everyone. It's raining AI today and we love it. We have Ilya Verbitsky, the founder of Web Storytelling, with us here today. And he is going to talk about constructing the past with knowledge graphs, empowering historians through Neo4j and JI. I'm sorry, and GenAI. Over to Ilya. Take it away.
Hello, my name is Ilya. Thank you for coming to this presentation. I'm the founder of Upstarting. It's a small boutique agency where we do AI and like Gen AI consultancy and help businesses to get sense of the data. And today we are going to talk about how knowledge graphs and Neo4j in particular helps historians and archaeologists to do their research and to find some relevance, some insights from the data. And to do that, we will go through like a few stages of how you can introduce RAG and AI into such projects. We start with basic RAG solutioning, and then we are going to enrich it, go to agentic RAG, and end up the session talking about MCP servers, where you can connect your databases to an LLM and talk about the data. But first of all, let's talk about the context of this. Archaeology, it's an interesting subject, and it's my hobby. Basically, in archaeology, there are a lot of information. There are a lot of publicly available databases across the internet, but sometimes it's difficult to find to understand like what is there, and archaeologists, when they do research, need to query multiple databases and try to find similarities about like different artifacts, or let's say they have an artifact that they want to do research for a particular period to see if this artifact basically from that period. Also, in archaeology, they trying to do like a cross-disciplinary research nowadays. That's why, let's say you have some historical like data, like historical documents, libraries, I know some geographical data, and when you join everything together, you can find a lot of insights. For this particular section, we are going to talk about numismatics in particular, because that's my hobby, and that's why I decided to work on this small project. Back to the history. Once I decided to learn about like Roman coins, which is an interesting and very big subject. But the problem is, since those coins are very, very old, and it's hard to figure out like what they are actually. You see some faces or some text on the coins, and it takes time to figure out like the epoch, the emperor, like where the coin is coming from. So knowledge graphs in particular, with some databases, can help you a lot to start understanding the subject and build your expertise. First, let's see like to the data which we're going to store in the database. Here you see Honorius, a coin from Roman Empire, and each coin has some standard data set. So it has an obverse and reverse. Here you see a portrait of an emperor, and then there is some text on it, and it's kind of like a standard text. Most of the like Roman coins have it. For example, the DN Honorius PF AVG means our Lord Honorius, the pious, the blessed emperor. And on the reverse side, usually Romans put something which is important, like they could you may see like some warriors or some events, because for them a coin was a piece of information which they wanted to use to educate the people who live in the empire about the culture, about the emperor, etc. And again, it has some standard set of properties. Usually, it's an image, and then again has some text, which is a standard text according to Roman numismatics. Once you if you once or if you decide to start collecting Roman coins, you will see there are a lot of different variations, types, and like different rulers, different periods. And there's a one database which is called OCRE, Online Coins of the Roman Empire. It's a huge data set where you can see information about most of the types which we know at this time. It has like tens of thousands of like different coins information. It's a collaborative project from American Numismatic Society and the University of New York. And as a researcher, you can go and download it. So the dataset follows a particular standard, so it's easy to download, parse it, and let's say in my case, I store it as a knowledge graph. So here on this slide, you can see how the knowledge graph looks. So basically, you have a coin, and the coin consists most of the information, and then there are some related nodes, which is like a authority, like the emperor who rules the country. You see like denominations, like materials, which could be like gold, silver, whatever. So once we have this information in Neo4j, we can start using different techniques to query this information and start asking questions. For example, you can like here on the screen, you can see like different AI and data integration tools which historians, numismatists, like, or archaeologists can use to make sense of the information they have. So they can use like RAGs. They can use agentic RAG where LLM itself decides based on your input what questions to ask and where information should come from. Like nowadays, academia tries to do some research about MCPs because if you have MCP servers, you can have your, for example, cloud desktop. You can connect your bunch of MCPs and do your research or work on your paper right from your LLM UI. So yeah, obviously they use like a knowledge graphs. They use some vector databases to find like similarity between different texts. Yeah, things like that. So for this project in particular, I decided to start with the simple RAG. So, for example, say I have a coin and I can get text from this coin, and then based on this text, I want my LLM to go to Neo4j, like find information about okay what this could be, and then return it back to me. And RAG is a term called for retrieval augmented generation. It's a technique which helps you to retrieve information and help you with text generation. Because LLM has a generic knowledge, but you have a database with a particular knowledge, and you want to use this knowledge as your main context for LLM. And if you use RAG, LLM mostly plays a role of like a text generation tool. RAG will help you to reduce hallucination and enrich your LLM with domain-specific knowledge. That's how it usually works. So let's say this is like this. That's me. Like I just like talk to my application and send a plain text message. The framework here this is your application, and for Neo4j, there is a Neo4j graph rack, which is open source library that helps you to build RAG workflows. So in this case, we just say, okay, question comes to this Neo4j rack tool, graph rack, and it will go to Neo4j itself. And since it's a plain, so it's like a plain text, plain English like sentence, it uses a vector database, which is available in Neo4j to get context. So once you have context, in our case, this is like a set of potential coins. We send the final request to actual LLM and get the response. To move forward, we need to talk a little bit about vector indexes. So vector indexes enable semantic search by storing and querying vector embeddings. What they do is you have text, and there are models which allow you to convert your text into a vector. So basically a set of numbers which you can store in vector database. And then what this database do is, let's say you have a text which you want to find. You convert the text which you want to find into vector. Your database tries to find similar vectors in its dataset, and the similar vectors. Like the similar vectors means the semantic meaning of the text which you persist in your vector index is close to what you're looking for. As of today, for this project, I used OpenAI, and OpenAI has two models developed by themselves for embeddings, and there's like a small and large models. And also, it supports an open source model which is called Olympiad Base V2 from V2. So if you want to use it in production, I would suggest you to start with small model, which provides like a quite good result, and the cost is reasonable, so it will not hit your budget quite heavily. Here on the screen you can see how you can create a vector index in Neo4j. So there's a create vector index command which you call, and it's important here to say the dimension of your vector. So this number is very important because each model has the dimension. And for example, if you create a vector for this model, and like tomorrow you decide to switch to a larger model, you cannot do it simply by changing this number in the index. You will have to drop the index, create a new one, and re-upload all the documents. And then the second important parameter is similarity function. That's basically a math function which you can use to find how close your vectors are. And we use cosine similarity, which is mostly good. It's kind of a standard way, and it's good enough for most of the projects. Okay, so once you've done that, you need to start ingest data into Neo4j. Yeah, you do your like normal Neo4j API calls to create a node, but since we have to work with embeddings, we need to pass that vector to Neo4j, and here I'm using OpenAI library to create an embedding. So there's like OpenAI embeddings create call, which gets the model, and it gives you back like the vector of numbers, and you just simply store it in your Neo4j, and it will be indexed, and then you can use it for search. In case of Roman coins, as I showed you earlier, usually obverse and reverse have some sort of like a text, which is a standard text. And if you try to find information using this text alone, then full text search, which is like standard search based, like kind of fuzzy matching against your text information in the database, it works a bit better than vector search, because vector search is more about the meaning and how close like two sentences semantically to each other. So in Neo4j, they support full text search as well. And again, you just have a command, create a full text search index, and you provide what attributes you want to use for index, and basically that's it. You just start normally creating nodes. And last but not least is a hybrid search. So hybrid search is a technique where you send your query to full text search index and to vector search index, and then you kind of analyze. So you get you get results from both queries, and you compare the relevance, and based on that you decide which answer is better. So it's basically like two queries against indexes and then union, and then you order like by relevance that takes the most relevant information. Neo4j GraphRag has a retriever for that, and so it's basically available for you out of the box. And like from my own experience, usually the hybrid search provides you the better results than full text search or vector search alone. But again, it really depending on your data set. So when the full text search works better, so basically again, if you have some exact term matching or you have like a structured text here in the end, you see an example. What's the coin with the end honor with PF AVG lettering. So from my experience, like this question would be answered better from full text search angle. On the other side, if you have a vague question like, okay, I have a Roman coin and there's an emperor standing frontally. It has like a meter address and it's facing right. So it's basically like a very vague question, and if you want to get like better results, it's better to use vector search in this case. So what's GraphRag? So GraphRag, it's a tool where you have your Neo4j graph database, which is your storage for the storage for your knowledge. Then you have a vector and full text search to find information relevant to a question. And then the last component of GraphRag is your LLM. And so LLM is doing reasoning. It takes findings from your vector search and full text search and creates the final answer. Usually this system architecture looks like this. You have the database, you have a bunch of indexes, and I use OpenAI as an LLM, but you can choose any other LLM, it doesn't matter. And then you provide your template. So here on the screen, you can see some sample code, how you can set up your GraphRag. You create a driver, you say, okay, I'm going to use like this embedding model, and you define the retriever, you define your LLM, and you just merge everything together as a GraphRag object and run search. So it was like a basic technique, but sometimes simple GraphRag is not enough. You need to use some optimization techniques for your queries. For example, like one of the optimization technique is contextual question rewriting. Here, so it uses your message history. For example, you're chatting with your RAG system, and contextual question rewriting will understand, okay, let's say if you use some reference like he, it, it will rewrite a question and make it more reasonable for LLM. Another technique how you can optimize your RAG is a step-back prompting. So what this tool is doing is, instead of asking a precise question, like for example, like who won the US election in 2020, this information might not be available in your LLM. You can say, okay, please take a look to candidates from 2020 and identify a potential winner. So you go from the exact question to more like an open question, and usually it can improve your search relevance and the answer. Another technique, it's more the graph architecture approach, how you basically generate the context. So usually if you have a RAG tool, you have a document, let's say it's your book, and then you break your book into chunks, and then you you run a query to Neo4j. It will find like a few chunks, it uses chunks as a context for your LLM. But instead of doing this, because you may find some like non-relevant information, you can break a document into sections. So let's say you have a book, then you break it into chapters, and then you break each chapter to chunks. And now when you query your LLM, you query your RAG, you get chunks. But instead of sending only those chunks to the LLM to get the final answer, you go one step up and get the chapter itself. So you send the chapter itself to LLM to generate the answer. Again, it can provide you more relevant information. Now we have a problem. So RAG is mostly works for Q&A type of systems where you have like a search and summary, but it doesn't do like reasoning. It cannot do like a multi-step and go to like, different databases. You can solve this problem using the agentic RAG approach. So with agentic RAG, you have your normal RAG, which knows how to query your vector database, and in our case, like Neo4j. But then you have a planner who can take your question, then understand what tools you can use to get relevant information from this question, and then you will call those tools. So agentic RAG workflow looks like this. Your user sends a query. For example, I want to get all the Roman coins from Julius Caesar. And then Planner knows, okay, Planner knows that you have like a few tools. For example, there is a tool, it's like a Python function, for example, that knows how to query all coins by imperial. There is a tool which knows how to query all coins by age, by epoch. So Planner will understand, okay, this is a tool that you can use, and then you call those tools, it will call you like those tools to get the relevant context. And then it takes all the context and send it back to LLM to generate the final answer. So here on the screen, you can see how the tool looks like. So in OpenAI case, and each LLM has its own standard of defining the tools. In OpenAI case, you say, okay, I have a function, you have a description, so OpenAI will know what the function is doing, and you say, okay, I have those parameters which we can pass to the tool. And here on the screen, you can see the planner code. So the planner will just say, oh, okay, OpenAI, I have this question, and I have a particular, like my tools that can retrieve information. Please tell me what to do. OpenAI will understand, analyze your question and say, oh, okay, I can see that you can call like some tools with parameters to get the relevant information, and you just go call those tools, and you aggregate all the results and pass it back to OpenAI saying, okay, now I have my context, please generate the response. So last but not least, so once you have those agentic approach, so you have your agents, for example, you can try to build an MCP server. So MCP is it's a protocol which provides you a standard how your agent, how LLM can talk to third-party APIs. So this is like one way how you extend your LLM. Once when you have your MCP server installed, your workflow will look like this. You can say, okay, I have this like describe Roman coin tool. You say, okay, describe Roman coin tool, and then you send your question. In case of Claude, because I tested this with Claude Desktop, so Claude say, okay, I know this is like MCP function coming from MCP server. It will send this text to the MCP server, and MCP server will process your request, sends back the response, and Claude Desktop will use this response to generate the final answer for you. Like from my experience, like the fastest possible way to build an MCP server is by using a Python and fast MCP. So with fast MCP, you just define your MCP server, and then you create a function which gets a query, and you say, okay, this is MCP tool. So whenever your LLM decide to call your MCP server, it will call this function, and then you can do whatever you basically want. And like the final step is once you have your tool ready, you just tell, in my case, Cloud Desktop, how to run the tool. Okay, before we finish, I want to show you how the MCP tool looks in reality, because I showed you just the template. What you really need to do is when you build your MCP server, you have to provide instructions, and for each functions, you have to provide the deep documentation, because more information you provide here, like with this, all this information will be passed by your LLM. There is a high chance that your tool will be properly called by the LLM. And I think that's it. Thank you. Thank you very much for coming to this presentation. I know it probably be like a lot of information in 30 minutes. I put all slides and all sample code to my GitHub account. Just feel free to go there, and it will be all open source, and you can play around with all the code you can see here.
Wonderful. History and AI. Just love that combination. Thank you so much, Ilya, for such an intriguing session. And thank you to our attendees for joining us today. Hope you all are as excited for the next one. We have we have just posted a survey for you to collect the feedback. Please make sure you complete that survey before you leave this particular session. We do have a couple of minutes if you want to stay back and do a QA with Ilya. Please feel free to do so. So I don't see a lot of questions on the chat. So I believe that it brings us to the end of this session. A lot of you have been asking how we could access today's recordings, right? So all of these sessions will be recorded and it will be shared with you in a couple of weeks' time. Thank you so much, everybody. Appreciate your time. Bye bye.
Thank you very much for coming. Bye.